Hello.
Can you say
Look
your name?
at you. It's a full room. It's a beautiful room. You guys are incredible. And you girls. I use guys generally. It's bad. Anyway, hi, I'm Tejas. It is very nice to be here. It is a beautiful city. Thanks to can we hear it for the organizers, actually? This has been such an amazing conference. So, my name is Tejas. Does this change slides? Excellent. My name is Tejas. That's pronounced like the second half of contagious. It's a little mnemonic to help you because it is an exotic name somewhat. And I live in Berlin, Germany, and work for a company called, Contiamo. If I don't complain or if I'm happy, this is probably why. It's one of the greatest places to work, and I love it so much. It's with these incredible people. I go to work every day and I'm just happy. This is a conversation that happened today. I missed French baking and he's just going to make me another cake. I mean, come on. But anyway, I'm here to talk to you today about TypeScript. I love TypeScript. I use TypeScript. I say things on Twitter like I use React plus TypeScript daily and I've never looked back. It is so enjoyable. I also teach TypeScript. So my friend Joe, I had the pleasure of, with him, looking at some TypeScript code and increasing the strictness gradually to where now his code scales quite well. And at the end of it, he is now a fan of TypeScript, rightfully. So I think it is an art and just a beautiful system that can help any code base. That's what I'm here to talk to you about today. And I have one more reference, and this is by a prominent voice in the industry. And so pay attention to every word that he says, because the next slide. You ready? You looking? Something about TypeScript, and it's by Ricky, who is Bay. It's a joke, but I think it is something to talk about, and that's what I'm here to do today. So TypeScript. Why am I talking about TypeScript? Why are we talking about TypeScript? There's a survey for web developers called the State of JS. How many of you have heard of this State of JS survey? Right. And so if you've looked at the State of JS of 2018, what you'll see is that TypeScript is growing. It's growing fast. The smallest metric there is the salmon-colored metric, that is people who have used it and who would not use it again. For me, this is something very exciting because the people who have used it and would use it again, the people who have heard of it but would like to learn, all these metrics are on the up, and rightfully so. More specifically to where we're at right now, what we can see is in the whole world, under 50% of respondents to the survey use TypeScript. And so I'd say it's a little bit underrepresented here in Helsinki. And I'd like to talk about it today in the hope that I can show you some of the value that it can add to your code base and improve your life. Like, it just makes you more confident and happier with your code. And so before we can do any of that, let's talk about why TypeScript. Simon Sinek, a famous thought leader guy, often says, start with the why. And that's what I want to do today. Why TypeScript? I've spent a lot of time thinking about it. Why should we use TypeScript? And here's why I prefer TypeScript. And here's quite honestly why I have a harder time working in entirely JavaScript code bases. TypeScript gives you contracts. You very clearly define this thing looks like this, works like this. And then the contract is expected to be valid throughout your code base. If a contract is invalid, you have a red squiggly underline in each file that violates the contract. And because of this, you're able to go through your code base and make it a little bit safer so that your users, the people who actually pay for your software, don't have runtime exceptions and bad experiences. Once you define these contracts, you then have confidence. You know if something's out of date, if something is no longer supported. You know where it is, and you can go fix it ahead of runtime. And this allows you to build code in a very confident way. If you have a code base of 20,000 plus files, TypeScript, you'll really see the value there. We certainly do. And once you have these contracts that give you confidence, that allows you to scale really, really fast. Just think about it, because if you change a contract and you have a giant code base and you need to add something, you already have defined what things are. And this opens the door to things like auto-completion, or as VS Code calls it, IntelliSense, and so on. That's actually all powered by type inference. So why TypeScript? Well, TypeScript gives us contracts that give us confidence at scale. And I'd like to show you very briefly, this isn't anything special, it isn't anything sophisticated, it's a very simple demo of TypeScript. And so if we go here, And what we're going to do is define a contract. So I'll just define a little interface. And I'll say, so this is a contract. It's called an interface in TypeScript. And many of you already know this. So I'm not trying to impress anyone here. I'm just showing you what TypeScript does. Password is a string. And so I'm just saying, so I have this thing in my code base. It's called a user. And this is how it looks. And so now imagine I have a code base of another file, source, file1.ts, for example. And I have const, any const, whatever. And I say this is a user. And so now this red squiggly underline here tells me, actually, you're saying this is a user, but it's not really a user because you need name, email, and password. And so I have, based on that, I now have auto-completion because it expects certain things. This is OK, I guess. Bryant, hello, whatever. Name is, of course, the most famous basketball player who I just thought of. And password is something like this, right? And so now the red squiggly underline has gone away, and our contract is obeyed. And now this is nice for like one file, but just imagine at scale what happens. So you have another file somewhere, Michael, whatever. The values can stay. This is all well and good until, say, for example, something changes. Say, for example, there's a law that says you're no longer allowed to store email addresses for anyone. Delete them from your code base, or else when you're audited, you're in trouble, right? And so with TypeScript, imagine with me now, you have hundreds of places in your code base where these users are used. We delete this one property from the contract, and then everything is now red. And so we're able to go through how many ever files we have, and update the way we use code. And once we do that, why is it complaining now? Oh, because I do have email. All right. Once we do that, there's no more red, and we have confidence that we are safe. This is quite valuable. This is an object, so you can't really have a runtime exception easily. But in the case that the user is not really an object, but another type of primitive, say a number or something, and you try to access the property.password on a number, in JavaScript you will get a runtime exception, a reference error, that you can't read property email of number. And so this reduces your runtime exceptions and really allows you to confidently scale your code base. Let's shift focus a little bit and talk now about design systems. There have been some incredible talks at this conference already about design systems. Who was here yesterday for... Right? And how good were they? They were very, so we got a thumbs up right here. I think we should give a little love to this is incredible. I'm not going to say a lot about design systems because people like Andre, Artyom have already said quite a bit, but I will give you a little bit of context for the sake of this talk. This is a tweet from Pascal. And he says, Design Systems Apocalypse, the movie. The year is 2022, a world without design systems. 98% of the population is unemployed. Everything is falling apart. But one guy has the idea to use the same button in 3 places again, writes a Medium article, and saves the world. I think that's hilarious. It's funny because it's true. InVision, the famous designer/developer bridging app for prototyping, says the secret to connecting designers and developers is design systems. And because of this, we see a significant amount of growth with the amount of design systems available on the internet today. It's almost as if each team has their own design system because of the intrinsic value that these primitives, these symbols can give you. And so why design systems? Well, design systems, if you think about it, in preparing this talk, design systems give you contracts, right? A button is a button. And buttons behave like buttons, and they look like buttons. If you use a design system more geared towards a certain behavior, so for example, I think of Reach UI from Ryan Florence. It comes with accessibility guarantees. It's a UI library provided that provides accessibility. So if you use a modal box or a drop-down from Reach UI, you have guarantees. The contract says that it's keyboard accessible, it's screen reader accessible, and you just know it, and the contract is valid. Once you have these contracts, they allow you to confidently just place a button or a modal box, and it does what you expect it to do. The third point Who wants to guess what the third point is? When you have these contracts that allow you to confidently build UIs, you can then scale really, really, really well. At Contiamo, we had a feature that we once had to build, and we kind of expected, it'd probably take a couple days. It was fairly significant. But we have a design system that is entirely in TypeScript, and it took us like 15 minutes or so. We didn't even write any code. We just kind of pressed tab, tab, enter, tab, tab, enter, and let the editor do the work. That was when I saw it working, I had to just stop and back away from the computer. I was like, what in the world? And I have to shout out, my coworker Fabian did a lot of work to make that possible. So why design systems? Well, they give you contracts that allow you to code confidently at scale. And so based on what we just saw, it's quite clear that TypeScript and the building blocks or design systems are a powerful combination. They're like a match made in heaven. They give you symmetrical value to each other. And so at where I work, we have a design system that we use called Operational UI. It is open source, and it's something we've been working on for, I think, about 2 years or so. It is fully TypeScript, and it is a very central core part of all of the UI work we do. We just plop in things, build them, and they work. And since it's TypeScript, we have auto-completion and so on. What's especially important when you have a library is documentation. I've been burned before by stale documentation, or if there's a breaking change and a prop is no longer valid. With JavaScript, you don't really know. TypeScript solves this problem. For our documentation so far, we use a solution called React Style Guidist. How many of you have heard of Style Guidist? Style Guidist is incredible. It gives us so much value because, as you know, it parses a Markdown file, extracts a code snippet, runs the code snippet, the React component in the browser, while also giving you an interactive playground where you can play with your component. It's really helpful, and for us, it has added so much value to our workflows. In fact, I just want to take a quick moment and recognize Artyom for his incredible. Can we hear it for Artyom? It is incredible. And I would say it is Artyom, but it's the entire team, the entire open source contributors to this project. I applaud each of you because it is a gift to us. And so I was very fascinated by this. I thought this is incredible. This is such a valuable tool. And I wanted to add a feature to it because I figure if it has TypeScript playgrounds, that'd be incredible. But my curiosity was beyond that of adding a feature via pull request. Right? I wanted to see, okay, how does this actually work? How does this tick? And so I decided to reverse engineer it just to understand kind of the moving parts. This is a huge hack. I'm not promoting my library and saying use it in production. Do not. We don't even use it in production yet. But it was very interesting to learn some of the lessons there. And this is what I want to share with you today, is the case study of what it was like to learn this. So I call it Operational Style Guide because it's the style guide for operational. Anyway, and the features that I wanted to add were that it is TypeScript first, so the implementation, but also everything from start to finish is 100% covered with TypeScript. The code playgrounds in the browser, I want them to be powered by the underlying engine of Visual Studio Code, so the Monaco Editor. If you've used Code Sandbox before they moved fully to VS Code as an experimental feature, and maybe now in production, I don't know, it was the Monaco Editor. And of course, I wanted to build it with modern React via hooks. And so I'd actually like to show that to you really briefly. So what we have is Operational UI Style Guide, and it looks, it's quite unassuming, I guess. And so we have a section for hooks and a section for all of the components. And I just wanted to understand how Style Guidist works, and so very similar. This is our GitHub repo, and if you go to SRC, we have a list of just UI components here, and they map directly to what we have in the side nav. In fact, if we go to, let's say, avatar, we have this. This is the Markdown file. This is the README. And I want you to look closely at this, because it's just a heading with code. And here, we have the same thing. This is processed from the README. So the README is the source of truth. And so this snippet, we take it and render it here. And there's this little view code button, very similar to Style Guidist. I tried to learn as much as I could. View code. And it says self-documentation. Press Alt plus space inside a component for available props and docs. This here is the Monaco editor that is in the browser here. And so what that means is I get the niceties of TypeScript directly in the style guide. To demonstrate that, I can I can play around with it. So I can change the name, and you can watch it live update. So let's see. Let's put a new name in here and just watch it update for fun. Right? From React Finland. You get the idea. I tried to spell his last name, but it's difficult. Anyway, I can also, the value that this adds is because it's all TypeScript and all of the types are described, the contracts are now in the browser essentially. What I can do is press Alt space, and I have all of the props available to me right here. So I can say, okay, I didn't even know, there's a prop called hide initials. What does that do? Enter. Oh, okay, the initials are gone. Kind of useless, but whatever. What else do I have? I have a title. What is that? Is that like a job title? Organizer. Oh, cool. Nice. What else can I do? I have size. And if I click this little I here, I can actually see more documentation that is parsed from Markdown. So I could put a GIF or GIF, depending on where you land. I could put one of those in here. It's quite cool to discover my own library. So size. I will naively assume this is a number. So 40 pixels? No. 400? No. Why? What's the problem? Number is not assignable to small or medium. Okay, so then do I get autocomplete? Oh, I do, so medium. And so I get to learn my own library here in a very interactive way. But the bigger value is, if my documentation is ever out of date or stale because of a breaking change, I think we even have an example. Right here, avatar is not defined. My docs are broken. And this is live. View code, I can see why, and I can just go change the Markdown file and fix it. Turns out I am not importing avatar. There. And so this is what I wanted to create with Operational Style Guide. Now, I would like to spend the next few minutes of the talk kind of dissecting it and showing you the moving parts about it to maybe see how you can integrate similar tooling into your workflows to help you. I will say, again, it's a huge hack and, caveat, caveat, caveat. Let's go straight in. So we have a terminal right here. Is that big enough? Can you all see? Nobody's saying anything, so I guess. Sarah, thank you. Operational docs. Let's open code insiders, because I live on the freaking edge. And I'm not even sure it's a good idea to use code insiders. I like new, unstable things. And so let's look at the code base here. So let's start right at the beginning. Source index.tsx. What we see here is we import React. This is pretty standard. The only thing that's different is we bootstrap Monaco and then return a promise. Once we finish doing Monaco things, we render the app. If we look at the main entry point, there's a lot going on here, but let's just look at the JSX and go from there. We wrap the entire library, the entire style guide in a wrapper from the library itself. This is our way of eating our own dog food. And we use a layout with a header bar and a logo, and a main area with a page whose title is documentation. And what that looks like in the browser is this. So header bar, layout, page, title, documentation. This is how JSX just describes our view. If we have an active component, in this case we do, it's avatar. We show a card with the title of the active component, and we use this Markdown to Monaco thing. And that's what we have here. Card, title, Markdown to Monaco. We go to Markdown to Monaco. And we use a tool internally called React Markdown, which is it takes pieces of the Markdown AST and allows you to render them as React components. And that's what we're doing here. So we say React Markdown has this source, which is the Markdown file for the component, and use these renderers. So for headings, show a title component, but this is the one that's really interesting. For code snippets, we wrap it in an error boundary. This thing has error boundaries upon error boundaries upon error boundaries. I wasn't sure why I added so many. I was just very paranoid, and you'll see why, because hacks. So we have an error boundary, and we have a playground in here. Well, what's a playground? A playground looks like this. So we have another error boundary. Can you tell this was scary for me? And we have a rendered example, a play button. If you're playing, a shiny message that says press Alt space, and the Monaco editor. That's it. And what does that look like? Well, we saw it already here. So we have the rendered example, the play button, message, Monaco editor. You with me so far? Great. And so now let's go one level deeper. I want to show you two things particularly, this rendered example and the Monaco Editor component. And so let's look at the rendered. Oh, and also this only happens if it's a JS or TSX snippet. So if we just have just an arbitrary piece of code in there, like maybe in select, yeah, if it's not annotated with JSX or TSX, it just shows like monospaced fonts. And so let's quickly go back and look at the rendered example component. Ooh, it's really small. Right, rendered example. So it accepts a prop. It accepts code as a prop, and that's the source code from the Markdown file. But we do very interesting things here. We disable tslint because we're actually doing something here that is dangerous and probably not a good idea. We have this function called transpile that we're importing from TypeScript in the browser. And we take TypeScript from the source code, transpile it, and then like eval it, and then execute it directly. Now you see why I've added error boundaries upon error boundaries. But hey, it works, so I guess that's okay, right? And so the error boundaries are because of doing things like right, like the error boundary catches it. But of course, if it's still syntactically valid, it doesn't. So, is he here? There he is. Okay, Ricky, everybody. Right. So, it's all fun and games, people. So that's anti-pattern number one probably. And let's go back to the playground.tsx. Down on the bottom here, we have this Monaco editor, and this is something that's quite interesting. It's for reference, it's this thing right here. So what we have is a Monaco container, and we pass a ref, so it's a styled component. If we look at the definition, it's just literally just a styled div with a margin. And we pass a ref through emotion, which is the CSS and JS library, to the underlying div. And this is important because it's a mutable reference. The element may or may not exist in the DOM. And mutable references usually always should be used with refs. Should use ref mutable. Anyway, so what we do is let's scroll up, and when the DOM node exists, it's very interesting because Monaco requires a piece of DOM to mount itself into, and it's interesting to try and have that be controlled with React. Regardless, if we have the DOM node, right? And if we have a model, we'll talk about what a model is at a later stage. Then create an instance of the Monaco editor in this DOM node with these options and assign them to a ref. And so now we have a reference to the Monaco instance that we can do stuff with. What's interesting here is the model. As I said, we'll come to that in just a second. Now, once we've mounted the editor and passed it our code, we can do things like use effect to auto-size the height of the editor. So what this says is every time the height of your DOM node increases, trigger a layout on the Monaco editor. And that you can see that happening here. Every time I press enter, the div increases in height. You can also scroll to the top as people type, adjust the height, and so on. Trigger IntelliSense with Alt plus space, which, I mean, look at this. It's a bitwise operation. If this doesn't tell you I'm a elite hacker, I don't know what will. I found it from the source code. And so what that does is it just does this. So I'm pressing Alt space right here, and it opens that up. That's what the code does. And again, it's an effect. So all of this is in use effect. And of course, lastly, we just return the component with the ref. But there is perhaps one thing that is more interesting than others to me as I implemented this, and that is this concept of a model. Because if you've looked at library code, TypeScript library code, it's very rare that you have all of the type declarations in one place. We use tools like Webpack and Rollup to put all of our code in one place, in one bundle, but with type declarations, they usually live alongside their counterpart, their source code, even after TypeScript compiles them. I'll illustrate that here by opening our design system, operational UI, in the editor, and what we'll see is a file tree. Let's go to the compiled library code. So this is compiled TypeScript. This is what we ship to NPM. And you can see each component has its folder. We have an index, an entry point of the declaration files, and it just imports and exports a bunch of stuff. we go into, say, for example, page areas.d.ts, and this also imports and exports. So you need some type of dependency graph based on the file system. But of course, in this environment, you don't have a file system. You're in a browser. So how do you handle the imports and exports? And this was something that I found really interesting because I was unable to find documentation about it. I might do a pull request, but it fascinates me that Monaco is such a powerful tool. Microsoft has done such an incredible job. It kind of simulates a file system in it. And that's what I want to show you, and then we can talk about some takeaways. To do that, we won't look at the code I wrote. We'll actually just create something from scratch. We'll use the open source Monaco Editor from GitHub. It's on Microsoft/Monaco Editor. And what we're concerned with is actually getting it into a project and using it. And to do that, we'll go to the docs. They have an ES module version, and we're progressive, so that's what we're going to use. And we're going to use Parcel as our bundler of choice, mainly because it's zero config and blazing fast, like every other bundler out there. So it's quite cool because they give you pre-written code, so I can kind of do copy-paste driven development here. Ha! Isn't that cool? So it says have an index.js and so on. So I'm just going to literally copy-paste and see what happens. Let's go to so I have a project here called My Editor, and as you can see, there's nothing. There's node modules, a package JSON, and yarn lock. In fact, I can show you what's in my package JSON. Literally nothing except a start script. And this called some files that the README is going to tell us to do. So let's create a file. We're using Parcel, so we need an entry point. So we'll create index.html. We also need a JavaScript entry point to reference, index.js. Okay. And let's go from there. Let's open it up in the editor. Close everything that was open. You saw nothing. All right. And so we're going to copy paste from the documentation. Index.js. Let's go. Copy. Paste. OK. Next. Build workers.sh. I don't even let's just copy paste and then talk about it later. Build workers.sh. Paste. OK, what else? It says run this script here. I'm going to take this and alias it in my package JSON for convenience. In fact, I've already done that right here. So now that it's here, I can just do yarn start, and I'll have something running. So I'll do yarn start. Wait a second, though. My files are empty. My index.html is literally empty, so it's not going to, has no entry point. We need a DOM node in which to mount the editor. So I'll create a div. I will also give it a height. This is important. And I will reference my newly created index.js right here. OK, save. Now we can go ahead and fire off yarn start. And it's going to bundle everything together and work for us. This takes about 5 seconds or so because of caching. All right, 6 seconds. And so what we have here is the Monaco editor. Literally, I can write my JavaScript and so on. I need to move a little bit fast, so we'll skim over some details. Let's see how this works with TypeScript. Interface, user, name, string, email, string. We're doing the same example. OK, it's too much. Anyway, so we have this, but it's yelling at us. Why? Well, it's because it says types can only be used in a .ts file. If we go back and look at the source code we just compiled in index.js, what are we actually doing here? So we're populating window.monaco environment with a getWorker URL function, and it just figures out where the workers live. Well, what are workers? Monaco Editor gives you language niceties like syntax highlighting or red squiggly underlines by running a language service in another thread, right? And so your browser communicates with this thing, and it works for you based on file type. We don't need JSON or CSS, so we're going to get rid of that. And what this does is it creates an instance of the editor in this DOM node with this function. And that's how we have a default value here. And also, this is the important part. If we change it to TypeScript, now, oops, close the editor. See, my live coding is so fun when it works. OK, so I have the editor back. And let's go back here to the browser. And what we'll see is a huge blank screen. There we go. So now this is TypeScript. So if I bring back my TypeScript snippet, interface foo, var string, and we say const a is foo, then we should have Exactly, a red underline with auto-completion. Great. But as we saw, library code is modular. There's imports and exports. So let's take this and replace the value with our new code here. But let's say I actually don't want to do that. I want to import foo from my lib. Okay. So this, I want to do this, but can I? I can't. It says I can't find this module, and we don't have a file system in the browser, so what do? Well, we simulate one. We use something called a model with the Monaco Editor. And so what we're going to do is we're going to create it here. Const model equals Monaco dot, and watch this auto-completion, because this is the value of TypeScript. Monaco dot editor dot create model. Okay? And the model has a value, a language, and a file path. And this file path is a path on this virtual file system. So the value is our code snippet that we just wrote, and we'll export the interface. It is a TypeScript model, and it lives in, and this is the cool part, you would never guess this, it lives in node modules slash my library slash index.d.ts. And it's quite cool, because what Monaco does internally is it looks for node modules and something in node modules with this name here. And it finds that file and then imports the type. So now this is still not going to work because we're not using this model at all. So nothing actually changed. What we need to do is create a model actually based on this input as well. So we'll do that right now. So const, let's just do this. Okay. We will relocate that somewhere else for now. So this is our model, and we import something. It's a TypeScript model. This will not live here, but this is, at this point, this is just our entry point. And we'll say, instead of all this configuration, we'll just say use my model. Right. And so we should still have excellent. It doesn't work, and it doesn't even like the white space at this point. That's weird that it doesn't do that. So what's it? Declare modifier. Okay, it's a d.ts file in my model. It shouldn't be. Right. And so now if I want to export this from a virtual library, I need to add a library to Monaco. And we'll do this, and then we'll wrap up. So I will do monaco.languages.typescript.add TypeScript defaults, .add extra lib. And the content of my library that I'm exporting types from is this. And this library lives at file, 3 slashes, not 2, node modules slash my library slash index.d.ts. And lastly, I need to tell Monaco what kind of module resolution I have. So languages.typescript TypeScript defaults .set compiler options module resolution. Look at this. It writes itself. Is TypeScript. Module resolution kind is a Node.js module. And once I do this, I should be able to not have a red squiggly underline there anymore, but this is valid now because it gets types from my exported library. And this is exactly what we do here to have our library in the file system. Now, let's wrap up. There are some takeaways from this. There are 3 takeaways that are technical and 3 takeaways that are not so technical, but I think are still valuable. Takeaway number 1. Static type analysis is valuable. It gives you contracts and confidence at scale. Takeaway number 2, working with Monaco is fascinating. It runs these workers in separate threads, and we saw how you can inject type declarations at runtime. And lastly, when you work with mutable references and hooks, you probably should use a ref. Non-technical takeaways, learning usually always comes with hacks. Hacks are okay. Hacks are how you learn. They're good. I'm a firm believer in the ideology of make it work, make it right, and then make it fast. But it's important for it to work, and sometimes you need to figure stuff out. It's okay. There is not one tool to rule them all. React Style Guidist is incredible. So is Storybook. React is amazing. So is Svelte. So is Angular, so is Vue, depending on your use case. I think we have a really rich ecosystem on the web platform, and I would suggest we ought not compete with each other, but complete each other. And lastly, docs contributions are still contributions. I've heard far too many people say, hey, I contribute to this project, but no code, I just write docs, so I guess it's not, No, it is! It's valuable, because if you've ever used docs that are out of date, it is a pain point. And so if you've ever contributed just docs to anything, I want to applaud you on stage today, because it's valuable. That is all of my time. Thank you so much for having me at React Finland. Appreciate you guys.